So we're going to continue finding equations for lines given different bits of information now. The first 12 problems we solved two different ways, but the problems were essentially the same. The problems gave me a slope and a point, and they asked me to find an equation, one using the y equals mx plus b method, the other using the y minus y1 equals m times x minus x1 method. The next few problems, they tell me to use the point slope formula again. I'm gonna actually solve problem 14 two ways. I may regret this, but I will. Let me look at the answers. 14 and 13, the answers are so similar. I'm gonna do 14. Regardless of what equation I use to solve the problem, whether I use the y equals mx plus b approach or the y minus y1 equals m times x minus x1 approach, anytime I need to find an equation of a line that has both an x and a y, I need a point and a slope. I have 2 points, but I don't have a slope. So what I need to do first for problem 14 is find my slope. And then I'm going to have too much information. I'm going to have 2 points and a slope. So to find my slope, I'm going to do y coordinate of the second point minus y coordinate of the first point in the numerator of a fraction. In the denominator of that fraction, x coordinate of the second point minus x coordinate of the first point. This is going to give me the fraction -3 over +3. That's going to give me m equal to -1. Students think they like having choice, but trust me, students generally having choice is a bad thing because they start to make bad choices. So I'm going to show you two different ways to get the answer. One, I can use the point slope formula with either of the points. It doesn't matter which formula you use, and it doesn't matter which point you use. They both will lead to the same answer, which is good because there's only one equation that fits what it needs to fit. So I'm going to do this twice. I'm going to use the y minus y1 equals m times x minus x1 approach that we did in problems 7 through 12. And I'm going to find the equation using the y equals mx plus b method that we did in problems 1 through 6. And I don't really care which one you use. The instructions say to use the left one, but if you like the right method better, use it. So let me get the equation using the left method. For the y1, I'm going to plug in 5. For the m, I'm going to plug in -1. And for the x1, I'm going to plug in 3. This is going to give me y minus 5. Clearing the parentheses, on the right-hand side, I get -1 times x, which is I'm going to write as -1 times x. And -1 times 3 is +3. Now I'm going to plus 5 plus 5. And for an answer, using the first point and the point slope formula, I get y equals -1x plus 8. You don't need to write that -1. You could suppress the -1 and write an answer of -x plus 8. Let me show the other approach. The other approach is I have to know some information. The other approach involves putting the slope in my answer preceding the x, and then using the y equals mx plus b formula and the information to find the b. So this other approach that we learned for problems 1 through 6, I'll plug in 2 for y in the y equals mx plus b equation. I'll plug in -1 for m. I'll plug in 6 for x. And I'll leave the b as the unknown. This is going to give me now 2 equals -6 plus b. I'm going to add 6 and add 6, and I'll get 8 equals to b. I'm going to take that 8 and put it in my answer. Because it's positive, I'm going to put it after a plus sign. So you get exactly the same answers, regardless of the method that you use, regardless of the point that you choose. You've got freedom, and I'm going to use this method because I generally think students do better with that method than this method, because students always forget to do this algebra and they just put the wrong number in for b. I put a little star next to 15 telling myself I better do 15 with you, specifically because when I wrote my key I made a mistake, and I'm just checking my key as much as anything. So let's do 15 together. You can pause the video and try 15 using whichever method you feel most confident with. Regardless of if you're using the y minus y1 equals m times x minus x1 formula, or if you're using the y equals mx plus b formula, we need the slope. So I'm going to find the slope first. My slope is going to be m equals 10 minus 14 over 4 minus 1. And again, if you're feeling skittish about doing algebra in your head, press buttons, and it gives me negative 4/3 for the slope. I didn't have negative 4/3 for the slope in my answer, so I automatically made it wrong. Now I need to commit to using whichever point I want to use, and there isn't really a point here that's screaming to be used. I like points that have zeros and small numbers. I don't see particularly small numbers, and I don't see zeros, so I'm just going to pick the first point. So I'm going to pick the first point. You could pick the second point. We both have to use the slope of negative 4/3, and I like so much better using the y minus y1 equals m times x minus x1 method. That's what I'm going to choose, but you are welcome to use the other method. Our answer should be the same. For this method, I'm going to plug 14 in for y1. I'm going to plug negative 4/3 in for m, and I'm going to plug in 1 for x1. I'm going to leave the left side y minus 14, and on the right side I'm going to go negative 4/3 times x. That's going to give me negative 4/3 x. And then this I can do in my head. Fractions I don't like to do in my head, but negative 4/3 times negative 1, that's multiplying two negatives, should give me a positive, and then any number times 1 is just itself, so that's going to give me positive 4/3. I'm almost done. I'm going to finish by minusing 4/3 from both sides. I'm going to finish by minusing 14 from both sides. Need to get the y isolated. Don't know why I just said what I said, but I said something that was wrong. Oh boy. That's 4. I'm trying to do math in my head and it's not happening. I'll pull out my calculator in a second, but for those of you that are comfortable, this is right side is 4/3 minus 42/3. That 14 I can multiply by 3/3 and make it 42/3. Now I have 4/3 minus 42/3. That's going to be negative 38/3. And I still have a wrong answer. My gosh. Let me do this math here on my calculator. So 4/3 minus 14 minus 38/3. I believe I'm right. My key had a mistake, and I still think it has a mistake. I'll check it off screen, but not right now. So fractions shouldn't really slow you down, because if you're not comfortable doing fractions, then you can press buttons. If you do math well in your head, then this business that I did over here, you should be striving to do math in your head without having to show every single step. Okay, that's the third style of problem. So the first two styles of problems, they were the same question. I gave you a slope and a point, asked you to use two different methods to find the equation for the line. The next four problems, I gave you 2 points. We needed to find a slope. After we found a slope, we needed to pick whichever the 2 points looks more appealing to us. And then we needed to use the method that we preferred, either the first method that we did for the first 6 problems or the second method that we did for the problems 7 through 12. The next problems ask us to find equations of parallel lines. I don't know why this is such a common question, but you always get this question in an algebra class at this level. But it's not a skill that I remember needing in higher math. Finding equations of lines, boy, that comes up a lot in higher math. But parallel lines, not the most common question in a higher math class. So each of the problems between 17 and 20 tell me to use the y minus y1 equals m times x minus x1 formula to find the equation of the line, just because I think that's the better method to use for most students. But eventually, when we get down to the point where we're trying to find the equation for a line, you could use the y equals mx plus b approach if you prefer it. Each of the problems, 17, 18, and 19, 20, give me a point, which is good, but they don't give me a slope. And anytime I'm going to find an equation of a line that has both an x and a y, I need both a point and a slope. I could have more than one point. It turns out that that's not bad, but I have to have at least one point and the only one slope. So for this problem, I know what the point is. The reason we did section 3.2b about parallel and perpendicular lines is because I knew this was coming. I'm trying to create an equation that's parallel to the given equation. And I know lots of things about parallel lines, but the big thing is lines that are parallel have exactly equal slopes. Parallel means equal or same slopes. So the given line has a slope of 9 because it's in y equal mx plus b form, and the number in front of the x is the slope. So the given line has a slope m equal to 9. It's in y equals mx plus b form. The number preceding the x is the slope. My desired line, because it needs to be parallel, has to have the equal slope, so it has to have the slope of 9. I'm going to find my equation now. I have a point and a slope, and I like the y minus y1 equals m times x minus x1 approach, so that's what I'm going to use. I'm going to use the value of y that's given in the point and put it in for y sub 1. So the left-hand side of my equation is going to be y minus negative 5. I'm going to use the m that I got logically, knowing that my line is going to be parallel to the given line, so my slope needs to be the same as the slope of the given line. So I'll plug 9 in for my m. And for the x sub 1, I'm going to take the 2 from the point. Now I just need to clean this up. On the left-hand side, the double negative, I could make positive. And on the right-hand side, I'm going to clear the parentheses by going 9 times 2 and 9 times negative 2. That gives me y plus 5 equals 9x minus 18. And now I'm going to minus 5, minus 5. This is going to give me y equals to 9x minus 23 for what I believe is an answer to number 18. I'm going to pull out my graphing calculator and show you that I can check this on my graphing calculator. In order to check this, I need to graph both lines and show you that they're parallel. And I don't care to do this by hand right now. So you don't need to do this, but I'm just going to show you that I'm correct. I'm going to graph the original problem that I needed to be parallel to, 9x plus 8. And I'm going to graph my answer, 9x minus 23. My calculator will first draw the original equation, and then it's drawing my answer. See how they're dead parallel. So I know my answer is right. But I didn't need to graph them because my lines have the same slope, so I knew they were going to be parallel. May never bring out this calculator again. I just wanted to show you that my answer was right visually, and I didn't want to take 10 minutes to do it. Let's do 19 together because it has a fraction. Maybe pause the video and try 19 would be fantastic. 19, I need to find a line, an equation of a line that passes through the point 8, negative 3. So that's part of what I need. But it's not everything I need, because to find an equation for a line, I need both a point and a slope. That's to find an equation of a line that has both an x and a y. I need a point and a slope. And it's so easy to get the slope because the given line has a slope of 3/4. And my line needs to be parallel, so my line needs to have the same slope. Because in order to be parallel, your slope has to be the same. So I had to logic out the slope part of this. Now I'm going to use the y minus y1 equals m times x minus x1. I'll almost never use the y equals mx plus b approach, but you're welcome to use it if you prefer it. Into my y minus y1 side, I'm going to change the y1 to negative 3. And into my m times x minus x1 side, I'm going to plug 3/4 in for m and 8 in for x1. Now I'm going to clean this up. On the left-hand side, the double negative, I can make a positive, and I can rewrite the left-hand side as y plus 3. I'm going to clear the parentheses on the right-hand side. I'm going to multiply 3/4 by x and get 3/4 x. And then I'm going to multiply 3/4 times negative 8. I'll do it in my head, then I'll do it on my calculator. If you're comfortable doing math in your head, then let's work through this together. By hand, I would cancel the 4 with the negative 8. The 4 would become a 1. The 8 would become a negative 2. Fraction's going to be gone because the only denominator turns to 1. And I would just multiply the 3 and the negative 2 and get negative 6. If you couldn't do that, then you would just do this, do 3/4 times negative 8, and it gives me the negative 6. Basically done. Just going to subtract 3 from both sides. On the left-hand side, I'll be left with the y. On the right-hand side, I have the 3/4 x, and after the 3/4 x, I'm going to get a negative 9, because both the numbers, negative 6 and negative 3, are negative. And I would just add those and make them negative. All right. Okay. Next style of problems, basically the same, except instead of finding an equation of a parallel line, we're finding an equation of a perpendicular line. So problems 21 through 34 ask me to use the point slope formula, or I'm sorry, use the slope, or ask me to use the slope intercept form. I'm going to use the point slope form all the time because I like it better, and you have your choice. So use the method that you like once you determine the point and the slope to find the equation of the line. Immediately, well, I know my point, that's a freebie, that's no work whatsoever, that's given to me. I also know the slope of the perpendicular line. The slope of the line perpendicular to mine is the number in front of the x in the equation that's given to me. So the slope of the line that's perpendicular to the one that I'm going to find is -1/4. That's not the slope of my lines, because perpendicular lines have slopes that have opposite signs and the reciprocals. So my line, I'm going to create its slope by finding the reciprocal of 1/4. The reciprocal of 1/4 is 4/1, or just 4, and I'm going to change the sign, because to create a slope of a perpendicular line, you need to flip the sign and take the reciprocal. I'm going to say the slope of my line is going to be +4. It's the reciprocal of the slope of the perpendicular line with opposite signs. Now I'm just going to continue using my strategy of the formula y minus y1 equals m times x minus x1, because that's the strategy most students do best with, even though they might think they like the y equals mx plus b approach. Realistically, this is the money approach. So I took the information that I either was given or logicked out, plugged them into the formula. Now I'm just going to do the algebra to clean up and solve for y. I'm not even talking through the algebra, I'm just figuring it out. And I believe that's a good answer for 22. We'll do 23 together because it's a fraction. You can pause the video and give 23 a go if you like. 23, same deal. It wants me to find an equation of a line that's perpendicular to a given line, and it gives me a point. Anytime I'm asked to find an equation for a line that has both an x and a y, I need to know a point, and I need to know a slope. Because I'm finding a line perpendicular to a given line, I can't just use the slope of the given line. The given line is solved for y, so the slope of the given line is the number in front of its x. The slope of the given line is m equals 2/5. If I was trying to find a parallel line, I could use that. But I'm trying to find a perpendicular line, so I need to tweak that, knowing that perpendicular lines have slopes that have opposite signs and slopes that are reciprocals. So I took the reciprocal of the given slope, made a 5/2, and I changed the sign. So in problem 23, my line needs to have a slope of -5/2. Now I'm going to push through. The y minus y1 equals m times x minus x1 formula. And for the y1 I put -1. And for the m I put -5/2. And for the x1 I put -8, even though it looks like -81. I'm going to make my double negatives positive. Then I'm going to clear the parentheses on the right hand side. To clear the parentheses on the right hand side, I go -5/2 times x, which is just -5/2 x. And then I do -5/2 times +8. And if I'm comfortable doing this math without a calculator, I'd cancel the 2 and the 8 and get negative 5 times 4, which is negative 20 after the negative 5 halves x. If I needed to, I could just do negative 5 halves times 8 on my calculator to figure out that minus 20 ends the right-hand side. Now I'm just going to finish up minus 1 from both sides to solve for y. On my right-hand side, both numbers are negative, so I'll add them and keep them negative. We're kind of deep into this, but there's some quick problems that come up. I want to do those before we get to the part 3 of this video, because these are the problems that don't have any algebra. They require logic and not the formulas that we've been using. Very specifically, problems 25, 26, 27, and 28, I fit all 4 of them on this screen because they take so little algebra. They ask me to find an equation of a vertical line that passes through the given point. I created some scribbles at some point that I don't know what I did with my scribbles. Oh well. I created some scribbles about vertical lines and horizontal lines, but since I've recycled them, it's okay. We need to remember that vertical lines, all vertical lines, have an equation written x equal to some number. I can't use the point slope form or the slope intercept form when the equation only has an x or when the equation only has a y. These are logic problems and not algebra problems. If I'm asked to find an equation of a vertical line, I know the answer can be written and should be written in the form x equal to some number, and I just have to decide on the number to make it equal to, and it's not rocket science to figure out the number that I'm going to need in problem 26. If I need a vertical line that goes through the point 5, 6, well, I better get that 5 into my equation. Because the vertical line, x equals 5, graphs exactly like this, and then somewheres that line passes through the 5.56. So immediately when the instructions told me I needed to find a vertical line, I knew my equation was going to have an x but not a y, and I looked at the information and I stole the x from it. I didn't worry about the y. I'll do the same for 28. 28's in the same grouping where I need to find an equation of a vertical line. I know all equations for vertical lines can be written x equal to some number, and it has to fit what the question 28 wants, and the only x I see is negative 4 in problem 28 because the negative 6 is a y. So no algebra to do for any time I'm asked to find a vertical line or a horizontal line, because the equations that I have both x's and y's, and these don't have both x's and y's. 29 through 32, again, I jammed 4 problems on one sheet because there's no algebra. Horizontal lines have equations that only have y's and they don't have x's. So I'm not going to use the slope-intercept form. I'm not going to use the point-slope form. I'm not going to do any algebra to find the equation. I'm just going to use logic. I know for each of the problems, 29, 30, 31, and 32, the equation that I'm going to write has to be written as y equal to some number. That's why I'm not using the point-slope formula or the slope-intercept formula, because those formulas have both x's and y's. And then I just need to understand what number needs to go in my equation to get the correct answer. And it's just going to be the y-coordinate of the point. It has to be y equal to something, and I couldn't think of anything else other than the y that's given. So those are the freebies, but if you don't know the logic there, you can't just get there. So I'm going to pause the video. We're going to do a part 3. It's the word problems, but they're friendly-ish word problems.